because I think that this can be the beginning of a series of research activities, innovation activities, and so on, which could be very beneficial for the general context, which is the matter at hand, and the general context in our countries. I come from Extremadura, which is a region which is not that attractive at the scientific and technological level. And what we're trying to do is to show that perhaps that doesn't reflect reality. I think this is going to be the last plenary conference, right? And I had prepared some slides. I changed them 2 times. I cannot change them anymore, but I will try and avoid repeating the things that have already been said, and I will try to shed some light on some aspects too. So I think that in the next conference, perhaps we should talk about the fact that faults are a very important problem, but why isn't that problem being solved? I mean, if it's a problem which is concerning for us and it costs, I don't know how many million you said it costs to us, 430 or so. Anyway, why aren't we solving this problem? Well, I wanted to put this question on the table, and I really want to know how many public entities that talk about this subject matter have R&D and I departments that actually focus on this type of issues. I mean, I'm talking about insurance companies, I'm talking about the National Institute for Health and Safety and Work, I'm talking about all the administrative bodies that do administration tasks, but they don't even consider investing 1% of their budget or 0.75% of their budget in this, in developing research and technological innovation projects on the subject matter. And I think this is something that is ever present in this country. And another concept would be that of training. Who are the professionals that should really take action here? Because there is a problem. If, for instance, I take a pressure platform to study STABILOMETRY, and I see that nothing happens, the reason why nothing happens is because I'm not using the right tool, because the dynamics of the pressure center integrates movements of the whole body, everything that happens above the ankle. So there's compensating movement, some other aggravating movements, and we need to be very careful. Those who teach biomechanics and motor control in occupational therapy and in medicine, they need to consider these aspects, because in Spain we have a very important problem. We need to reorganize the active forces in the scientific and technical environment. And from our ivory tower, we are willing to help with anything they ask from us, but we need to all get further involved. And another point that I wanted to put on the table, because I'm possibly not going to have enough time to mention everything that I want to talk about, because I never have enough time to talk about everything I want to talk about. But anyway, another very important for me is loss of balance. From the neuromechanical standpoint, this is a motor problem that it could be subject to solutions A, B, C, or D based on the physiological and morphological features of the individual, or based on the conditions of the environment or based on the individual's experience or motor education, and based on organizational aspects that have to do with the workspace, with working hours, etc. These are aspects that I'm really interested in. So solutions A, B, C, or D are selected. And these are solutions that can lead to a fall or not, based on all the different aspects that I mentioned. But for those of us that work in research or in academics, what we have to do is to look for an optimal situation or for an optimal solution, because unbalance can be beneficial. Actually, in many sports, it is necessary to create an imbalance in the body, and this is what I need to say about this as a biomechanical professional. But from the standpoint of ergonomics, we also need to study how this posture and balance can be translated into effects in the educational, work, or home context, and also in leisure too. And by the way, Joaquin Sabina, who was showed earlier, this artist, is like Bob Dylan to the Anglo-Saxon world. So no one is safe from falling. So in my opinion, we need to develop a system to perform scientific and technological developments in this area. We took part in this master's degree in 2005 with the Madariaga Scholarship to prevent labor hazards. And we talked about the importance of technical footwear to prevent occupational risks. And even though a lot of water has gone under the bridge since then, I think that everything is now becoming to translate into interesting actions and very interesting individuals involved in this. And I would like to, of course, introduce ergonomic criteria, and I think I'm going to need the mouse for that. This is what we do in our lab. And this is a simulation of a trip. At the bottom, you can see that using quite a real-time image analysis system based on electromagnetic sensors, what we've done is to characterize the motor pattern that was in use when the trip fell. In our computer, we can simulate any situation. Sorry, but when the microphone, when the sphere is away from the microphone, we really cannot hear what he's saying. Sorry about that. And this is something that I actually introduced yesterday because you were talking about the problems with the room and so on. And this is quite a new system that simulates resistance when using a wheelchair. For instance, we can talk about anywhere based on the pavement that we are going to be using the wheelchair around. And this is the first in the world of its kind. And this allows me to establish a link between physical effort in terms of mechanical work and metabolic consumption involved in the use of a wheelchair. And in Extremadura, we are very focused on this because of cork, and we think that cork is an excellent material, and by the way, it has great ecological value for Extremadura and its forestry. And we think that cork could be first-class material to lay on pavements or where wheelchairs are to be used.
Okay, so the problem that worries us is very well defined. We have a series of human factors that have to be developed within an environment which is, as I said, workplace, home, leisure area, and it has to be done with safety, comfort, and efficiency. So in order to achieve these, because efficiency has not really been tackled during this conference. Ergonomics without efficiency does not exist. It can be comfort, but ergonomics without efficiency do not exist. So in order to be able to answer to this topic, we need engineering. And this is absolutely necessary, and we need to evaluate human factors in all of their dimensions: morphological, functional, metabolical, perception, personality, motivation, and so on. So as we can see, our Anglo-Saxon friends have led the way, and we need to wake up and follow them. And we need to do things much faster than they had been done up till now, and with much more sense and meaning, I believe. What you see to your left-hand side I think is saying something about this part of the image. It was an essay we did 12, 14 years ago for an industrial design thesis where we were interested in knowing, because I always wonder, and I still haven't found the answer, I wonder for what reason does a step have to be 20 centimeters high? I mean, what's the reason why a step needs to be 20 centimeters high? Well, there are architectural interventions, accessibility interventions, and still the step is 20 centimeters high ever since that regulation was approved. And we don't consider that the average height of humans changes every decade, and we grow 1 centimeter every decade. So why is it 20 centimeters? Well, because the rule says that. And what's the basis for the regulation? And that's the question that I ask myself. So the central idea of my intervention would be the following: how we're going to manage for those who project biomechanics to also think about ergonomics. So that's what we want. So how architects can understand that what they're projecting, or engineers, industrial engineers, what they're designing, now, how do they know that what they design is functional for the users who are going to use it? Because, okay, so you're doing it, but what will I do in those premises? So that is why this is very important. So we started analyzing ladder designs or stair designs, and there we saw that, well, here you can see it. This is the vertical strength with a strength platform. It was registered, both going up and down. And you see that when going up, it is normal. But when going down, you see that this strength, this force, this vertical force increases 30 to 40%. So imagine that I have, well, this actually is a problem. And that is why the ladies who do the Oscars and then have to go down the stairs have important problems, because you have to think about your mass center from an X center, and you have to control it. You have to control the movement of the pressure center within a surface that is relatively small. It's 4 or 5 square centimeters 1 square centimeter for the heel and 4 or 5 centimeters, which is the contact of the forefoot. So this is a motor problem, a very difficult problem. It's not easy to do this. So this is what we did 12 years ago, if I'm not wrong. And now we do it with this technology. So it's the same thing we did, but now we have 2 force platforms. Instead of 2, we have 8. And instead of having a three-dimensional photography system, we have one that measures you on real time. This is what happens in my school, where I teach ergonomics. And they have fulfilled the norm. They have the anti-slippery surface, and they actually abide by the regulations. So trying once again to go from the analysis to the application, the essay you just saw with the simulator, which is the only simulation system that we currently have in Spain. It's the only one that exists in Spain, and it is in our lab, and we are proud to have managed to do so. Allows you on real time to analyze the biomechanics in all of its dimensions, because one of the inconvenience of biomechanics, one of the disadvantages was that it was relatively slow. But these problems have already been solved with quite some efficiency. So here I would show you the hip, knee, ankle articulation, how these 3 work. The joints, how they work. So here we have normal gait that I program with the speed, with the slope upwards or downwards. I can just change it. Then we have trip and recovery. Okay. So here we see the hip, the knee, and the ankle. Differences are not very important here. But here we clearly see that differences with regards to force. This would be the classical gait pattern, the vertical force. This would be the trip. So here you see that things have changed quite a bit. And what will cause the fall? Well, the fall, as a physical phenomenon, is going to be caused by the user's lack of capability of counteracting this projection movement of the mass center outside of its basis. So if it has enough strength and it reacts on time, it could cause an impulse, enough of a kinetic impulse towards the center to stop the rotation of the higher body and going back. So, because you know that upper limbs and the head as well as the chest represent 55% of the body. So the movement of the torso is very important. So who has measured this angular moment in falls? So we have this topic, which is the movement during the fall, but then there is training older people or special populations so that we can avoid, when it happens, when the cause happens, to avoid the fall. So here we clearly see this. And the third thing would be the muscular intervention. So the intervention of the muscles. We have anterior tibial and solar, which are the ones that control the ankle articulation. One flexes and the other one is plantar flexion and the other is dorsal flexion. And the interaction between these muscles is the one that will have X, Y, or Z consequences on the result of not the fall, but rather the postural unbalance as a physical phenomenon. I think he's talking about the highlighted area, saying that that is where we show the variability, I think he said, but he was speaking very far away from the mic. So I would like, because obviously my presentation is divided into 3 parts. There's the part that deals with quality control. So design that is user-centric, and then engineering that has to do with quality control. Then there's a part that has to do with biomechanics and ergonomics, and then we have a third part, which is 4.0 economics. So what are the advantages and what profit can we get out of not just solving the problem of the falls, which is a medical, social, and health issue, but rather as an industry, as a country, what can we get out of this if we solve it? This is very important. So in this context is where we find ourselves, and here we have a research we carried out with the University of Poland 9 years ago, which had as objective to train older people so that we could avoid falls. So this talk is complemented by the 2 presentations that I'll be doing later on, where I develop some of the topics that I touch upon here. This one was very long, but we had sent 3 presentations, I believe. So, summarizing, and I hope that I explain myself clearly, we have biomechanics with regards to gait and posture. Then we have the problem of motor control. And this was touched upon during the previous presentation, but nonetheless, I would like to insist on it, because I said that it depends on the morphological and functional characteristics of the user. Well, this is the functional evaluation part. But obviously, functional evaluation in this country is done differently by each lab. So you can rise in the morning and say, well, I'm going to create a new protocol for functional evaluation. So functional evaluation cannot be about evaluating the technique. It has to be about evaluating the possibilities, in-depth possibilities of the locomotor apparatus, such as isometric force, fatigability. It can be the degree of movement. But if you say, no, I'm going to do an evaluation, and I say if they know how to comb their hair or if they know how to wash their dishes, that's technique. That is not functional evaluation. That is an analysis of a technique that is applied in a certain context. So we have this topic here. We also have the topic of specificity of the training programs. For instance, if I had given a talk about cognitive topics, then I would talk about cognitive training. But since this is biomechanics and economics, I have to talk about physical exercise. Then mechanical properties of the environment. I really like the first presentation that we listened to. I really loved it. It has actually allowed me to see what it is that is currently done in cutting-edge technologies and urban planning based on biomechanical criteria. If you had seen the intensity of vibrations that a user is submitted to when they move around in their wheelchairs in any street of Spain, you would see that it is way above ISO regulations. And when this person falls down in a certain way due to their disability, the vibration will always affect the same point, and that is criminal. So we have to see these conditions, and that is why we then talk about cork that could be used for this. And then there is ergonomics and accessibility. It's not because I'm Greek, but ergonomics are much more than accessibility. Because ergonomics, in its definition, it's finding a compatibility between the skills and competencies of the user and the conditions of the environment so that they can go about their day-to-day with more comfort, more safety, and more efficiency. So this, which was called accessibility, should maybe be redefined, because I know that we come from different knowledge areas, but I think that the term accessibility somehow reduces the force of this topic, and words have a meaning, so we need to be careful with that.
Si hacemos bien las cosas, o si no las hacemos bien, porque
well, I'm not Spanish, but my kids are Spanish. I've been living in this country for 32 years, and it hurts for me to see that this country is missing out on opportunities constantly. It really hurts. So they told us in Greece that we need to start with criticism. We need to start with criticism. We have to start criticizing and then make a proposal. So we have two possibilities. Quality, or two main axes, because these are the main components, okay? So these are main components for advanced statistics. So the first one is the quality of design, and the second axis is the quality of production. So only one of these four things can happen. It's either a success, this is Germany, or Anglo-Saxon countries, because we know how to design and we produce well, or it will be a failure because we don't know how to design or how to produce. We don't have the technologies to do so. Or it will be an opportunity, a lost opportunity, or it will be a useless effort. So this is what we need to answer to. That is why I said that next time we would have to include this. I'm not going to tire you with this. Now, usability. We've talked about usability. Usability is a central concept. It is a seminal concept. Okay? And we translate usability, well, it actually comes from the English term usability, and we have created this word in Spanish because we didn't have one. So specific objectives for specific users in specific use context. If you want to just give one image to usability, think about sports footwear. Sports footwear are the image of usability, but no one has really paid enough attention to this sort of topics. And when I talk about sports footwear, I'm talking about technical footwear, and it's because performance is very important. It's actually Adidas, because Adidas decided to change the soles of football shoes and put nails on them. So, and that represents 60 billion euros. I might be exaggerating a bit, maybe, because for pedagogical reasons, I just want for the concept to be understood. So this is the modern trend of industrial design, which for a country such as Spain has great relevance, because this is a high added value to products and services. So we have to care for this. We need to really care for this. The designer, in any context, has the obligation of saying for what percentile of the population they're designing for. It's their obligation, it's a duty. If you design for 20% of the population or for 30 or 40 or 50% of the population, but you have to say it so that we know where we stand. And then we have to see whether it makes sense economically to invest, to keep on making progress or not. That's very important as well. This is a accredited institution that says this, and this is our duty. This is what we have to do, and then I'll end here unless you give me an extension. Or maybe I can just continue my presentation during a coffee break. So the variability of human factors, as I said previously, we have to consider it in all its characteristics, in all the characteristics of the most perfect machine invented by nature. And the epicenter of all things is ergonomics, because it's the only anthropocentric science that puts human beings at the center of any development. And we have to analyze, we have to study and consider the variability as a factor for design. And that is what we can do. And I think that it would help us be more efficient. Thank you very much for listening.